start to do it, which they probably will, just to make it a little bit more difficult. The hardest part of this is going to be converting in between different pressures. I don't know that they'll have you do a lot of it, but today what we're starting with is Dalton's law of partial pressures. And this is just the idea behind mixing gases. So if I have one gas in a balloon or in a container and I use our gas law formulas over there, I can figure out all sorts of stuff about it. I can figure out the temperature or the amount of moles or the pressure or the volume or all sorts of stuff. But what if I have two different gases mixed together? Now things become a little bit more difficult. And so the more gases I have mixed together, the more difficult it's going to be to try to figure out all of your information over here. But there's one thing that's actually pretty easy when I mix gases together. That's the pressure. The pressure is going to behave in a way that is easily kind of observable and easy to do the math on. And so that led us to the law, Dalton's law of partial pressure. So it says the gas law that states that the total pressure of a gas mixture, so when I mix two or more gases together, the total pressure is equal to the sum of the partial pressures of the individual gases. If I'm getting a sum, what am I doing? Adding it together. So what they're telling me here, when I mix a couple gases together, two or more gases, I mix them together, the total pressure for all the gases together is equal to if I just added up all the individual pressures for the individual gases. And so that leads us to this formula, which is one of the easier formulas. The total pressure for all the gases together is equal to the individual pressure of all the gases separately added together. Does that make sense? So all we're doing is adding here. If they ask you for the total pressure, you just add up all the individual pressures. If they give you the total and two of the pressures, you just need to subtract the individuals from the total to find out what that third one is. So today you're really only doing adding or subtracting with pressures, and that should be about it. So they have an example here. We know that pressure A is for the blue gas. It was 46 kilopascals. We opened up the valve for the red gas, gas B, and let in more gas, and my pressure went up to 138. So the total pressure for both gases is 138. The pressure for just gas A is 46. So what's the pressure for gas B? I just subtract it. It's 138, which is the total, minus 46, which is gas A, leaves 138 minus 46 is 92 for gas B. So simple math, just addition or subtraction, depending on how the problem is set up. And that's all they're really asking you to do. So, example, a mixture of gases containing methane, CH4, ethane, C2H6, and propane, C3H8, have an unknown total pressure. So I don't know the total pressure. If the partial pressures of the methane, ethane, and propane are 235 millimeters mercury, 452 millimeters mercury, and 294 millimeters mercury, respectively, what is the total pressure of the gas mixture? So for this one, they want to know the total pressure, and they give me the individual pressures. What do I do with them to get the total? Just add them together. You're not going to subtract, just adding. So because I want the total, I add up all the individuals, and that's going to be the total. So literally just add these three together. You don't need any conversions or anything. Add them together, you get your total, which is 981 millimeters mercury. If they give you the total, but only one or two of the individual pressures, then you need to subtract. You do the total minus the individuals, and what's left over has to be the gas that you're missing. And so it should be pretty straightforward. You're either adding or subtracting. I guess that's it. So you can go ahead and open up the assignment. It is already assignments happening. It's actually pretty short. So let's go ahead and take a look at it. Was it 7 questions? Not very long. So yeah, question number 2, they want the total pressure. You just need to add together the individual pressures. All the individuals together equals the total. What is this one? Student lab performing experiment. So they give you the partial pressures of A and B. The student then adds 1 mole of the third gas in. There's no change to the volume or temperature. Gas C using ideal gas law. The student's calculation is shown below. What has the total pressure of the gas become? Okay, so like for number 3, there's a lot of reading here, but they give me pressure for gas A and gas B. So here's the pressure for gas A, here's the pressure for gas B, and then they tell me that the student involved here does the calculations to figure out the pressure for gas C. So the student calculates the partial pressure of gas C using the ideal gas law. The student calculation is shown below, so here it is. And our answer is the pressure of gas C. So now I have A, B, and C, and they want to know what is the total pressure. I just have to add them together to get the total pressure. So literally for this one, you're just adding or subtracting. If you get stuck or can't figure it out, let me know, and I will pull it up on the board and show you how to get through it. But this one should be pretty easy today. So whenever you get done, find something quietly to work on. If you have any questions or want me to open up an old assignment, let me know. Ta-da. Ta-da on a Monday.